So our project was a duck feeding project, and I'm Cassidy Moore. So our goals for this project, we wanted to model a dynamic pond ecosystem with ducks, bread, and a dock to kind of show those feeding interactions. And we wanted to use MATLAB and MLPQ together to define object movement and interactions. And we wanted to simulate feeding behavior and environmental constraints. So for our database design, we have a pond that has the attributes of name, ID, location, and size. We have a dock with ID, name, location, time, and pond ID. And then we have pieces of bread that have ID, size, and a time. And then we have our ducks that have an ID, the pond ID, and the species. So in our first has relation between the pond and the dock, it's a one-to-one relationship. So one pond has one dock. And in our second has relationship, it's a one-to-many. So one pond has many ducks. And then our throws relation is also a one-to-many. So one dock can have many pieces of bread thrown from it. And then finally, we have our feeds relation, that's many to many. So many ducks can eat many pieces of bread. And so for some of our defined functions, we have a duck defined with ID and X and Y coordinates for its location, and it defines a duck using linear constraints. And then we have a bread with ID, X and Y for a location, and then T for time. And it models bread movement over time. And then we have our dock with ID, X, Y for location, and T for time, which represents a static dock structure with boundaries, but we added a time constraint onto this, and we'll show you why in our demo. So for our data sources, we created the ducks by making an outline of a duck in Draw.io that we could actually outline. So we made that little picture of a duck and saved it. And then we used the MATLAB script to create relations for the duck. And we could only do one duck at a time. And usually MATLAB likes to put it in the same place every time. So we figured out if we adjust the X and Y start points, then we can create another duck in a different position. And then we made our bread and our pond by calculating the rectangle relations by hand. And then we kind of just figured out where the bread should land and applied a linear function to that relation so that it would move linearly over however long we wanted. And then we created our dock using the MLPQ built-in function. I think it's just a polygon draw function that you could draw it out with your mouse, and then it will generate the relations for it. And so this is one of our queries that we had. So we wanted to see all the times that the pieces of bread are eaten. So for each piece of bread, we put in the ID and we got the max time that it was around, assuming that once it's gone, it's been eaten. So we found all of these and did a union of them all so that we could see that they were eaten at times 15, 17, 12, and so on. And then we kind of did the same thing here. We wanted to find what time all the pieces of bread were dropped into the pond. So for this one, we just found the minimum time with all of the IDs. And we could see that it was at 8, 5, 3, 1, and 0. So for this query, we wanted to find what time each of the ducks eat at. So to do this, for each of the duck IDs, we wanted to find the bread ID, the duck ID, and the bread time. So we took the ID for each of the ducks, and then we kind of looked at where they were on our graph, and we could query out so that we find the bread X and Y to find that first time it kind of really intersects with it. So we made those boundaries so that once it passes it, it shows that it's actually gotten to the duck. And then assuming that once it's right there, the duck would eat it. So we queried all of these out and we found them all. So when we put them all together, the X's here in the time to eat chart is all of the bread IDs, and the Y's are all of the duck IDs, and then we have all of our times. So we can see that duck 1 ate bread ID 3 at time 12. We see that duck 2 ate bread ID 1 at time 8, and duck 3 ate bread ID 4 at time 15, and so on from there. And so for this query, we wanted to find what bread pieces were in the pond at a certain time and where they were. So we picked time 10. So we queried out basically just to see, we got the bread ID, we got its X and Y coordinates, and then we said when it's at time 10. So for this, we found that the bread IDs 2, 3, 4, and 5 were all in the pond at time 10. So the first one was already eaten, and then our X and Y are actually shown more like in the constraints for the location, because it shows the actual full shape of the bread at the time, so it's just showing the location of the full object. So for our data transformations, we converted MLPQ constraints into polygon regions, and then we mapped time-dependent bread motion for visualization, and we aligned coordinate systems across MATLAB and MLPQ. So now we'll just do a quick demo. So as you could see on the left, we have all of our relations here. You can see we have all of the shape constraints for our ducks and whatnot with different IDs. But if we actually start an animation here and just put in a time for step here, once it starts, all the bread kind of disperses out. They all start from the duck and go towards the ducks kind of randomly, and they come in at different times. And then once it actually gets to a duck, it'll disappear, showing that it's been eaten. But you can see with this last piece of bread here, it will kind of stay there in the animation. So to fix this, if we just use the other animation function in MLPQ, we should be able to show it. And anything with time constraints will turn red. We just have time constraints on our dock so that we could actually show the full time of the last piece of bread disappearing. But you can see, you can adjust the step size on your own and kind of see where everything goes and where it ends up. And then finally, we could see this last piece disappear. Yep. And then we gave everything different colors to kind of all make it go together and look nice. So in conclusion, we successfully modeled the multi-agent interaction in the pond. We captured realistic duck movement and feeding behavior, and we integrated MATLAB visualization with MLPQ logic structure. In the future, we were thinking about adding duck and duck interactions and grouping patterns so that those ducks can actually move around. And we wanted to extend the bread movement to include water currents so that it has more accurate movement. And we thought about adding animation layers for improved visualization and doing things such as color changing. And for some of the duck movement, since we used the MLPQ script, we had a really hard time moving them because I think it broke the shape down into about like 30 different polygons. So it was a lot of math to do by hand to try and get them to move. But I think if we just simplified the ducks, we would be able to make them move around and we could kind of show that better, which would be nice to do for future work. Thank you.